Hello everyone. I hope the audio and the video is clear. Hello, good evening, good evening. I hope the audio and video is clear. I hope the audio and video is clear. Hello. Good evening everyone, good evening. I hope the audio and the video is clear. Once if it is clear, just say me it is clear so that I can start the lecture. Clear, right. Now today we are going to start the thermochemistry. Now this thermochemistry, it is very easy at the same time. Now some Tamil students are also coming to the class. The one who is resident from the Telangana and learning Tamil. Fine, good. Now this is very interesting and very easy, and it is a very important, but it will be somewhat little bit confused also. If we clear with the basics, then everything it will be clear for us. Now let's start our lecture. If you are having any doubt in the middle, you just give me the question mark so that I can get to know that you are having the doubt and I can clear your doubts whatever it is having. Okay, fine, right. Now we'll start with the lecture. Now before going to the lecture, here it is a very interesting thing is, 1 minute. Right. Now we'll see. First of all, what is the meaning of the thermodynamics? The one who is in the live, just say me hi. Once the one who is in the live, just say me hi so that I get to know how many of there in the live. Hi Praneeth. Still any other? Okay. Now, hi Vaishnavya, hi. Now, today we are going to deal with the chapter called the thermochemistry. Now, this thermochemistry is very important. Hello, namaste, Danshuk. Now, clear? Done. Hello, Dinesh. Right. Now, here this thermochemistry. What is the thermochemistry and what we are going to deal in the thermochemistry? Here we are going to deal with the different types of the enthalpies of the reaction. So what is the meaning of the heat of the reaction or enthalpy of the reaction? Let's suppose first we'll take one adiabatic wall. What is the meaning of the adiabatic wall? Which does not allow the exchange of the heat. Clear? Now in this adiabatic wall, let's suppose this is a water and this is a which one? Adiabatic wall, and this is a water. Clear? Now this water, we are going to measure the heat of this water, right? Let's suppose initially in this adiabatic wall, whatever the H2O we are having, the temperature of that H2O is T1, right? In this adiabatic wall, let's suppose one reaction is happening. Some reaction is happening. What is the meaning of the adiabatic wall? Which does not allow the exchange of the heat. Clear? Now, when this reaction is happening in this vessel, now whatever may be the heat exchange is happening, that heat exchange will be absorbed by the water. It will be absorbed by the water, right? Then the temperature will be the T2. Means the change in temperature of the water we can say whether the reaction is exothermic or endothermic. Clear? Means in this container, this is a adiabatic valve. If this adiabatic valve means it will not allow the exchange of the heat. So here whatever the water it is there in this container, initially it is having the T1 temperature. So if we do the reaction for this one, whatever may be the heat exchange it is happening in this reaction, that heat exchange will be what? That heat exchange will be absorbed by the which one? This water. When that heat exchange it has absorbed by the water, then either it may be the decrease in the temperature, either it may be the increasing in the temperature. Clear? Now, either it may be increasing in the temperature, either it may be the decrease in the temperature. Clear? Now, here based on this temperature difference, we can say whether the reaction is exothermic or whether the reaction is endothermic. Hi, Upender, hi. Now, whether the reaction is exo or whether the reaction is endo. Now, the same thing we know, right? Here, the energy change, if this energy change measured at constant temperature and constant pressure, we call it as, can anyone? See, this reaction, let's suppose whatever may be the energy change it has happened in this reaction at a constant temperature and constant pressure. At constant temperature and constant pressure if we measure, or whether if we measure at the constant pressure, now that we call it as the energy change at constant pressure for this reaction at constant pressure, what that we call it as a enthalpy, right? So if this reaction at constant pressure if we measure, that we call it as a at constant pressure we call it as enthalpy, that we call it as a enthalpy. Clear? Now at a constant volume if we measure, at a constant volume if we measure, what we call at constant volume if we measure, we call it as internal energy. Clear? We call it as internal energy, right? So the energy change at constant pressure if we measure, that we are calling it as a enthalpy. The energy change whichever maybe it is happening in this reaction at constant volume if we measure, we call it as a internal energy. So these are the different types of the enthalpies of the reaction and different types of the enthalpy of the reaction that we are going to see. So before going to that enthalpies of the reaction, first of all we have to clear the basics. Clear? Now what is the basics we have to clear? First we are going to see the relation between the delta H and the relation between delta H and delta U. Delta U or delta H. Hello Parth, hello. Now, clear? Delta H and the delta U. Now we know what is the enthalpy formula. Enthalpy formula we are having the H is equal to U plus PV. This is a one enthalpy formula we are having. For a larger change, delta H is equal to delta U plus P delta V. Now this formula at a constant pressure, because enthalpy of the reaction will be measured at the constant pressure, right? Clear? Now here at a constant pressure, here for this one at a constant pressure, delta H is equal to delta U plus delta PV. Clear? Now here for this one, for this formula, for a liquids, for the liquids and the solids, there will be the negligible change in the volume, right? For liquids and the solids if you take, there will be the negligible volume, means volume V will be equal to 0. If the V is equal to 0, delta H will be equal to delta U. Why? Because here the V will become 0, means this entire term will become 0. But for the gaseous, if you talk it for the gaseous molecule, for gaseous, clear? For the gaseous, which gases we are going to deal here? We are going to deal with the ideal gases, right? Now what is the ideal gas formula? P delta V is equal to delta NgRT. Actually, ideal gas formula PV is equal to nRT. So why I wrote the change in volume and the change in number of moles of gaseous products minus reactants? Because for any reaction, constant pressure, R is universal gas constant and the temperature is constant. Clear? Then which thermodynamic parameters are changing? Only these two thermodynamic parameters are changing, right? That's the reason delta V, and I wrote the delta Ng. Clear? Now here in this formula, P delta V is equal to delta Ng RT. So we can substitute in this one, right? In this formula, or you can take it as a 1. Now if you substitute in the 1, now the delta H is equal to delta U plus delta Ng RT. Delta Ng RT. Clear? Done? Now delta Ng RT. Now this is a one formula. What is the delta Ng here? Delta Ng is equal to number of moles of gaseous products minus number of moles of gaseous reactants. Clear? Number of moles of gaseous products and the number of moles of gaseous reactants. Right? Now here many of the students, they know the delta H and they know the delta U, they know the reaction, but they don't know the unit conversion. Many of the students in the thermochemistry, they will do the mistake in the unit conversions. Why they will do the unit conversion mistake? You know, the data they will give you in the joules, they will ask you in the kilojoules, or else data they will give you in the kilojoules, they will ask you in the joules. So there, which one will play? Sometimes instead of joules, they will ask you in the kilocalories. So here, which parameter will play? Here the universal gas constant R will play very crucial role. Which one will play? R will play very crucial role. So this is a very important point. Generally delta H and delta U will be measured at kilocalorie per mole or kilojoule per mole. So these unit conversions will play very crucial role. Then here, if they measured in kilocalorie per mole, then the R value you have to take it as 2 into 10 to the power minus 3 kilocalorie per Kelvin mole. You have to take. Suppose if they have measured in kilojoule per mole, then R value you have to take it as 8.314 into 10 to the power minus 3 kilojoule per Kelvin mole. Clear? Now these R values, if you remember, now many of the calculation you may not do mistake, because these R values in the 10 to the power minus 3, this R value in the 10 to the power minus 3, they will never and ever they will give you. So this in the unit conversion, this will play very crucial role. Okay, in the question data, if you have seen the kilocalorie per mole, blindly believe that R value you have to take it this one. If they are measuring in the kilojoule per mole, then R value you have to take it in this one. Clear? This R value will helpful for you to not to get any miscalculation, right? Now we are going to see here what is the delta Ng value for how to calculate the delta Ng for the given reaction. Let's suppose here this is number of moles of gaseous products and the number of moles of the gaseous reactant, right? Now if suppose I write one reaction, CaCO3 solid gives rise to CaO solid and CO2 gas, if they have given, they will ask you what is the delta Ng value for this one. Can anyone say me what is the delta Ng value for this one? And first one. Now the second one, N2 gas plus 3H2 gas gives rise to 2NH3 gas. Now what is the delta Ng value for this one? For the second one? For the first one, the delta Ng value will be the 1. Why the delta Ng value will be the 1? Delta Ng is the product side. This is a solid. Solids will be the 1. It will be the 0. Only number of moles of gaseous products minus number of moles of gaseous reactant. Here the product side number of moles of the gaseous one is 1. 1 minus 0, it will be the 1. Now here it will be the 2 minus 4. It will become minus 2. It will become minus 2. Right? Now, next one. Many of the students, they will do the mistake while calculating the delta Ng for this combustion reaction. What is the meaning of the combustion reaction? Now let's suppose the methane gas, it has heated in the presence of oxygen. Now it gives the CO2 plus H2O. So many of the time they will not give you the phases. Just they will give you the temperature. Just what they will give? They will give you the temperature. What they will give you? They will not give you this balanced reaction also. What the reaction they will give you? Now the combustion of the methane at a 25 degrees Celsius. Combustion of methane at a 25 degrees Celsius. Now what is the delta Ng value? What is the delta Ng value? And same combustion of methane at a 393 Kelvin. So what is the delta Ng value for the first one? What is the delta Ng value for the second one? Can anyone? What is the delta Ng value for the first one? What is the delta Ng value for the second one? What is the delta Ng value for the first one? What is the delta Ng value for the second one? First one is 0. First one is 0 you are saying. Now we'll see. Here the first one, here 25 degrees Celsius, right? Now this is first we have to balance. Here how many oxygens we are having? Total 3. Now here how many hydrogens we are having? 2. 2 hydrogens, so it will be 2. So this is gas and this is gas. But at 25 degrees centigrade, now H2O will be liquid, right? Now first one H2O will be liquid. So delta Ng will be the 1 minus 3. Then the first one will be the minus 2. First one will be the minus 2. Now at 393 Kelvin. At 393 Kelvin is nothing but how much? 120, 273. Now 100. It will be the first one is a minus 2. Now second one 393 Kelvin. 393 Kelvin is nothing but 120 degrees Celsius, right? 120 degrees Celsius means H2O will be in the, it is in the form of which one? Gas. Now this is in the form of the gas, right? Now the delta Ng value will become here how much? 3 minus 3. 3 minus 3 it will become 0. So you have to be very careful. So here the temperature will play very crucial role for the delta Ng value to calculate. Okay, to calculate the delta Ng value, what it will play? Very crucial role. Temperature will play very crucial role. You have to be very careful. I hope it is clear. I hope it is clear. 25 degrees Celsius, it is a liquid. So the delta Ng value is minus 2. For the 120 degrees Celsius, 393 Kelvin, 120 degrees Celsius, it is G and it is 0. Okay, right. Now we are going to see the some laws of thermochemistry which will be helpful for us. To identify the reaction. What? To identify the reactions. These laws of thermochemistry, if it is clear for you, whatever may be the reaction they have given, then it will be easily, you can easily identify and you can predict the answer. Clear? Now first we are going to see the laws of thermochemistry. Laws of thermochemistry. Now, what are the laws of thermochemistry? Now we'll see. First one, if the reaction is added, then the delta H is also added. First one, what? If a reaction is added, then delta H is also added. Clear? Now, how the reaction is added? Let's suppose A is converting into B. Now, its delta H1 will be some X kilojoule. Done. Now, next one. Some C is converting into D. Its delta H2 will be Y kilojoule. Right? Now, if you add the equation 1 and the equation 2, then it will become A plus C gives rise to B plus D. A plus C, B plus D. Then the new enthalpy of reaction. Good evening, Murli. The new enthalpy of reaction will become X plus Y kilojoule. Clear? Done. This is the first one. Second law. What is the meaning of the second? If the reaction is subtracted, then delta H is also subtracted. Now, how the delta H is also subtracted? Now, let's suppose A gives rise to B. Then some E gives rise to F. Let's suppose A gives rise to B, delta H1 will be some A kilojoule, right? Now, the delta H2 will be B kilojoule. Clear? Delta H1 will be the A kilojoule, delta H2 will be the B kilojoule. Now, if you want to subtract equation 2 by the equation 1, means here two cases we can do. Equation 1 and equation 2. This is the equation 1 and this is the equation 2. If you want to subtract the equation 2 subtracted by the equation 1, means you can interchange the reaction also. Interchanging the reaction, or if you reverse the reaction also, that indicates that what? Subtraction only. Or if you want to eliminate, you can interchange. So how to interchange this one? If you want to interchange this one, how to write the reaction? A gives rise to B. Then if you reverse this equation number 2, then the enthalpy of the reaction also should be, that value should also be what? It should be reversed. Then F gives rise to E. Now the delta H1 will be the A kilojoule. Then its delta H2 will become, before it is a positive, right? Now it will become negative. Negative kilojoule. Then if you add the reaction, A plus F gives rise to B plus E, then new delta H will become A minus B kilojoule. Clear? Now this is a one very key point you have to remember. So if you want to eliminate any of the reaction, so what you have to do? You have to reverse the reaction. When you did the reaction reverse, now its enthalpy of the reaction also will become reversed. Clear? Done. Next one. Third one. Now third one, if the stoichiometric coefficient X is multiplied, then the delta H is also multiplied. Now what is the meaning of stoichio? Now if stoichiometric coefficient, if into X, then the delta H will also multiplied with the X. What does that mean? If A plus B gives rise to C plus D, right? Its delta H is A kilojoule. Then for this reaction, if I multiplied with the 3, then the new reaction will become 3A 3B equal to 3C plus 3D. Now the delta H will become 3A kilojoule. Clear? Now if you divide, fourth one, if you divide stoichiometric coefficient, if you divide then the delta H also will be divided by the X. If you divided by the X, now that also will be divided by the X. Let's suppose one reaction A plus B gives rise to 2C plus 3D. Let's suppose 4D will take. Then it's a delta H is equal to A. If you divide this reaction by the 2, then it will become 2, then it will become 2, then it will become 1, because 2 by 1. Now this one will become what? This one will become 4, right? 4, and it will become 2D, and the enthalpy of reaction also should be divided by 2. Should be divided by 2. I hope it is clear. I hope it is clear. I hope it is clear. Now these are the some following. These are the some following. These are the some laws of thermochemistry. You have to remember. If you remember this one, now whatever may be the thermochemistry question they may ask, it will be clear for you. Now first we are going to see in that. First, before going to start the thermochemistry, first we are going to study about the heat of the reaction. Heat of the reaction. Now what is the heat of the reaction? Clear? Now what is the heat of the reaction? At particular temperature, the amount of heat absorbed or released when a chemical reaction takes place according to the stoichiometry equation. Clear? And the reactant products in that. Now here heat of the reaction at particular temperature. At a particular temperature, amount of heat absorbed or released, amount of heat absorbed or released when chemical reaction takes place. When chemical reaction taking place. Okay, right? Now here what are the factors that are influencing the heat of the reaction? First one we are going to see factors that are influencing the heat of the reaction. Factors influencing. What are the factors that are influencing heat of the reaction? Okay, heat of HOR I will write with the short form. First one, physical state of the reactants and the products. Physical state of the reactants and the products means, let's suppose delta H2 gas plus half O2 gas gives rise to H2O liquid, right? When the H2O liquid, when it has formed, its heat of the reaction value will be somewhat 60 minus 68, let us assume. Then the same thing, H2 gas plus half O2 gas at higher temperature at a 120 degrees Celsius. Now H2O, instead of H2O, it will give you the H2O gas, right? Then its enthalpy of the reaction will be high, that it is minus 57. Means as the physical state of the system changes or physical state of the products changes, enthalpy, heat of the reaction is also changing. Heat of the reaction is also changing. Means more the heat it is comes from the system, that it is reaching to the stability, right? See, if suppose it is a liquid, it is giving the less heat of the reaction. If suppose this is a gas, it is giving the high heat of the reaction. Now compared to the minus 68 and the minus 57, minus 57 is a higher value. Done? I hope it is clear. I hope it is clear. Now next one, the heat of the reaction, that with the effect of the temperature also, with the effect of the temperature, how the heat of the reaction is changing. How the heat of the reaction it is changing. Now we'll see the effect of the temperature. Now heat of the reaction it is explained. This how the effect of temperature, how the heat of the reaction is influencing, that it has explained on the basis of Kirchhoff's equation. This is very, very important. Kirchhoff's equation. Now what is the Kirchhoff equation? How the Kirchhoff equation it has came? Now we'll see. Here the delta H is equal to enthalpy of products minus enthalpy of the reactants. Now we know, if you differentiate this equation 1, now dou delta H at dt at a constant pressure is equal to dou delta H product by dou T at a constant pressure minus now dou enthalpy of reactants at dou T at R. Clear? Now we know dH by dt, dou H by dou T at a constant pressure, that it will be equal to the Cp. Now what is the meaning of the Cp? Molar heat capacity at a constant volume. Molar heat capacity at the constant volume. Now delta H will be equal to the Q, right? Qp. Now whatever may be the heat we have supplied at the constant pressure, that it is utilizing to change in the which one? Enthalpy. Same thing we have wrote it here, right? Now that if you substitute in the equation 1, now dou delta H by dt at P is equal to Cp of the products, Cp of the reactants. Clear? Now Cp of the product and the Cp of the reactants. Now here this one will become the delta Cp because change in enthalpy, right? Change in enthalpy. Done. Now here this we can write it as a dou H by dou T at P is equal to delta Cp. Delta Cp, because products minus reactants we can write it as a change of Cp, right? Done. Now here for the entire reaction, if you send the dt to the right hand side, then the dou H is equal to delta Cp dt, delta Cp dt. Now if you do the integration for this above reaction, if you do the integration for the above reaction from the H1 to H2, now dH is equal to delta Cp, because the Cp value is constant, from the T1 to T2 at dt. If you integrate, now this Kirchhoff equation formula you will get it as delta H2 minus delta H1 is equal to delta Cp T2 minus T1. Now this is a very important formula. Based on this formula we'll get the direct questions. Now what are the questions they are asking? With the help of the questions we will do, right? Now this formula for the enthalpy change, the same formula we can write it for the internal change also. For the internal change it will be the NCV, T2 minus T1. This is for the above one for the enthalpy change. Now this is for the internal change, internal energy. Done. Now the first one. Now next one, after the temperature, next one we are going to see the nature of the reaction, how the heat of the reaction is changing by the nature of the reaction. If the nature of the reaction changes, how the heat of the reaction is changing, now we are going to see. First one in the nature of the reaction, we are going to see the standard heat of formation, standard heat of formation or enthalpy of formation or enthalpy of formation. Now we'll see what is the meaning of the standard heat of formation or the enthalpy of formation. Before going to move to the standard heat of formation or enthalpy of the formation, we have to know the some substance standard states. Some substance standard state we have to know. So what are the standard states of the substance? Clear? Now what is the meaning of the standard state? Most stable physical state of a substance at 25 degrees centigrade temperature and 1 bar pressure. Now what is the standard state? 25 degrees Celsius and 1 bar pressure. 25 degrees Celsius and 1 bar pressure is a standard state. Clear? At this standard state, now this substance physical state or standard state you have to same. Now if you remember this one, Now half of the thermochemistry will become easy for you. Most of the cases, many of the students will write the reaction. For that reaction, only the which enthalpy of formation we have to consider, that data only they will give you, and the rest other, suppose H2, suppose O2, suppose bromine if it is in the liquid, Cl2 if it is in the gas, that it will be in the question, that it will be in the reaction, but the data they will not give you. And many of the students, they will get confused why they have not given the chlorine data, and they will skip it. But you have to consider that chlorine over there, it is present in the gas. So the standard enthalpy of formation of the chlorine is 0. So if they give or if they not give also, there is no need, or there is no need of the chlorine one, because we are not going to use that one. So these standard states you have to remember. If you remember, while calculation purpose, it will be easy for you. Now, my dear friend, if you want to become strong in the organic, first of all you have to clear with the first 3 chapters basics: atomic structure, classification of periodic table, chemical bonding. Then after that become strong in IUPAC. Then after that go with the basics of the GOC. Then you will become very much strong in the reaction mechanism. Okay, right. Now here substance. First of all, the substance we are going to see H2 comma O2 comma N2 comma F2 comma Cl2 comma CO2 comma SO2 comma CH4 comma, okay, now C2H2 comma, etc. Now these standard states, what are the standard states? Can anyone say me? These substance standard states are, can anyone say me what are the standard states? What is the standard state of the substance? What is the standard state of the substance? This all the substance standard states are gaseous, right? Now second one, H2O, Br2, Hg and C6H6. May I know what is the standard state of this substance? Second one standard states are the liquid, right? Now third one, sodium, magnesium, aluminium, glucose, clear? Now urea, and very important is a I2. Very important is a I2. These all will be exist in the nature as solid. These all will exist in the nature as solid. Next one, very important thing is for the carbon. Most of the cases, when to consider the carbon standard state, actually the carbon, it is having the allotrope, right? Carbon standard state is a graphite. Carbon standard state is a graphite. Next one will be the sulfur. Sulfur standard state will be the S8, that it is a rhombic. It is a rhombic. Done. Now the phosphorus. It is a white phosphorus and it will be exist in the nature as P4. It will be exist in the nature as P4. Clear? Now next one, and the next one, H plus aqueous. H plus aqueous is also considered as a 0. H plus aqueous is also considered as a 0, that you have to remember. Standard enthalpy of formation of the H plus aqueous. Done. Now here, what is the meaning of enthalpy of formation? Now what is the meaning of enthalpy of formation? Here, what is the meaning of the enthalpy of the formation? Means, now any substance that it should be formed, that also should be the 1 mole. See, now the amount of substance formed, that should be the 1 mole. Clear? Here formation means it should be at the product side. Okay, here this CO2, it should be formed and that to be in the 1 mole only. That should be also 1 mole only at the product side. And this CO2 should be formed from the that individual substance should be in the standard state. Oh, I hope it is clear. Means here this whatever the CO2 it has formed, that how the CO2 is formed, carbon plus oxygen, right? Now this carbon and oxygen should be in their standard state. Blindly believe that it should be in the standard. So here the carbon should be in the graphite, because graphite is the standard state for the carbon. Now for the oxygen, O2 is a gas. So these two are the, from its standard state only this CO2, 1 mole of CO2 is formed, and this one we call it as a enthalpy of formation. This one we call it as a enthalpy of formation. Some value you will get, enthalpy of formation. Let's suppose, if suppose instead of C graphite they have given the C diamond. C diamond plus O2 gas they have given, and they have given the CO2, and this is not the enthalpy of reaction. My dear friends, you have to be very careful, because here the carbon is not from its standard state. Carbon is not in the standard state, that's the reason it is not the enthalpy of reaction. Now I will write some reactions. You have to say me what are the standard states of this formed products. Now let's suppose here it is a H2O. Now say me here what is the standard states of the reactants. What are the standard state of its, this 1 mole of the H2O has been formed. Now what will be the reactant side? What will be the reactant side? Means here the hydrogen H2, and here it will be the oxygen. Now this 2 will be in the which standard state? What are the standard states of the oxygen, and what are the standard states of the H2O? No, I am not asking about the H2O. I am asking about the H2 and oxygen. I am asking about the H2 and the O2. I am asking gas. Both are at the gas. But what I said, product side should be at the 1 mole only. Product side, what it should be there? Product side it should be only 1 mole. If the product side, if it is in the 1 mole, whatever may be the unbalanced it is there, that we have to balance at the which side? Reactant side, right? We have to balance at the reactant side. Then we have to take it as a half O2. H2 plus half O2 we have to do. So if you want to calculate the enthalpy of this reaction, enthalpy of reaction or standard enthalpy of this reaction, if you want to calculate, so the standard enthalpy of formation of this reaction is equal to summation of number of moles of products into standard formation or standard enthalpy of formation of products minus summation of number of moles of reactants into standard enthalpy of formation of the reactant. Clear? Now this is a formula you have to remember for the enthalpy of formation. Clear? Now enthalpy of formation, this is a formula you have to remember. Done? Now next one. Here the next very important the concept they may ask for you is the which one? Here they will ask you enthalpy of combustion. Enthalpy of combustion. Now what is the meaning of enthalpy of combustion, and what we are going to see in the enthalpy of combustion? First one is the enthalpy of the formation. Now the heat of the reaction will be different. Second one we are going to see, that is the enthalpy of combustion. Enthalpy of combustion. Now what is the meaning of the enthalpy of combustion or heat of combustion? Now in this enthalpy of the combustion, at a particular temperature the amount of heat energy released when 1 mole of substance is burnt in excess of oxygen. Let's suppose this C graphite plus O2 gas gives rise to CO2. Now this one we call it as a enthalpy of combustion. Enthalpy of combustion. Now or else C2H6 plus C2H6 plus O2 gives rise to CO2 plus H2O. Now first of all what we have to do? We have to balance the carbons. How many carbons we are having? 2. So you have to balance with the 2. Next you have to balance the hydrogens. How many hydrogens we are having? 6. Total 3. Total now you have to balance the oxygen. How many oxygens we are having? 4. 4 plus 3, 7. So it should be the 7 by 2. It should be the 7 by 2. Now this one we call it as a enthalpy, standard enthalpy or enthalpy of combustion. Done. Enthalpy of combustion we used to call. Now enthalpy of the combustion, standard enthalpy of the formation. Many of the students they will get confused. Enthalpy of the combustion and the enthalpy of formation. Many of the students they will get confused. Now I will say one key point. If you remember the key point, now you will never and ever you will do the mistake in the enthalpy of formation question and enthalpy of combustion question. Just keep it in your mind and just listen. I mean, this key point, if you remember, you will never and ever you will do the mistake. Now what is that key point? Now you see key point for the enthalpy of formation and the enthalpy of combustion. What is the key point? First key point, in a question, if enthalpy of combustion, okay, this enthalpy of combustion data, enthalpy of combustion data is given, enthalpy of combustion data is given, then we have to use the formula, for the enthalpy of combustion data they have given. Then the enthalpy of the, for that reaction, whatever may be the heat of the reaction, it has happened in that reaction, they will ask. For that one, the formula we have to use, now the enthalpy of combustion of that reaction is equal to summation of number of moles of reactants into enthalpy of combustion of reactants minus summation of number of moles of products into enthalpy of combustion of products, Clear? Now this is a formula we have to use if in the question they have given the which data? Combustion data. In the question, if they have given the combustion data, enthalpy of the reaction or that enthalpy of that combustion of the reaction formula will become reactants minus products. Done. Now the next key point. In a question, if enthalpy of formation they have given. In the question, if enthalpy of formation they have given. In the question, what they have given? If the enthalpy of formation data they have given. In the question, if enthalpy of formation data is given, then the formula will become that enthalpy of combustion of that reaction will become summation of number of moles of products into enthalpy of formation of products minus summation of number of moles of reactants into enthalpy of formation of reactants. I hope it is clear. Now with the question, whatever may be the misconception or whatever may be the formulas or the key points I wrote, that it will be clear for you. Now see, with the question it will be clear for you. First one, let's suppose in the question what they have given, heat of combustion of carbon, hydrogen, methane. Heat of combustion of carbon, hydrogen, methane are minus x1, minus x2, minus x3 respectively. Okay. Now what is asking? Calculate the enthalpy of formation. Calculate the enthalpy of formation of CH4. Calculate the enthalpy of formation of CH4 is asking. Formation of the CH4 means what it should be there? Formation of the CH4 means it should be at the product side. And that carbon and the hydrogen should be in the standard state. Carbon and the hydrogen should be in the which one? Standard state. So, and it should be in the balanced one. Now, this is a actual reaction. But you have to, which formula we have to use now? For this question, we have to use the first formula or we have to use the second formula. Now you have to say me. If you say me that, then whatever may be the concept I am going to explain, that it will be clear for you. Now you say me. First formula we have to use or second formula we have to use? Right. We have to use the first formula, because here the combustion given. Whatever may be, they may ask in the question. But what they have given? He has given the combustion data. So the combustion data if they have given means the formula will be enthalpy of combustion of that reaction. Enthalpy of combustion of that reaction will become, now carbon how much they have given? Minus x1 plus 2 into minus x2. Clear? Minus of, now product side how many you are having? 1, right? Minus of minus x3. Then it will become x3 minus x1 minus 2x2. Now this one will be the answer. This one will be the answer. Clear? Now the combustion data they have given, right? So combustion data they have given means we have to use the first formula. Right. Next one. Next question. If suppose the enthalpy of formation of CO2, H2O, C2H5OH are minus Y1, minus, okay, wait, are minus Y1, minus Y2, minus Y3. Calculate the enthalpy of combustion. Calculate the enthalpy of combustion of C2H5OH. Calculate the enthalpy of combustion of C2H5OH. Now say me the answer. Now say me the answer. Like answer. Now just now how the answer I said x3 minus x1 minus 2x2, right? In the same manner you say me. Balance the reaction. Now see the reaction and say me. Don't be in hurry. Just read the question carefully. Read the question carefully and say me the answer. Enthalpy of formation of CO2, H2O and C2H5OH are Y1, Y2, Y3 respectively. That is respectively only. Sir, product minus reactants. So products minus reactants kada. Okay. Now the data they have given on the basis of enthalpy of formation, right? Data they have given on the basis of the enthalpy of the formation means products minus reactants. Okay, good. Products minus reactants. Now say me. This is not the formation one. Actually, only the CO2 and the H2O will be only formed. Now this is not the formation. Ethyl alcohol is not in the formation. Calculate the enthalpy of combustion of ethyl alcohol is asking. So calculate the enthalpy of combustion of ethyl alcohol means 2y1 minus 3y2 plus y3. Good. Now here how to solve this type of the question? Here enthalpy of combustion of ethyl alcohol is asking. Enthalpy of combustion of ethyl alcohol means C2H5OH plus O2 gives rise to CO2 plus H2O. It will ethyl alcohol is undergoing combustion. Yes, good. Now here how many carbons we are having? 2. So keep it as 2. How many hydrogens we are having? Total 6. So keep it as 3. Then it will become total how much it will become? Here how many? 4 plus 3. 4 plus 3 how much? 7. Already here we are having the 3. Then remaining less is 4, right? If you keep it as 3 here, 6 and 7. So balanced. Then the enthalpy of combustion. will be products minus reactants, right? Now CO2 how much they have given? Y1. So minus 2y1 plus H2O. H2O मध्ये again minus y2. So 3 into minus y2. 3 into minus y2. Now enthalpy of formation for the any species, if it is present in the standard state, that enthalpy of formation is 0, because oxygen is present in its standard state gas, right? Its enthalpy of formation is 0. Now plus, now ethyl alcohol, how much they have given? Y3. So into minus y3, into minus y3, then it will become, then how it will become, sorry, minus into minus, this will the minus into minus, it will become plus, then it will become plus. So 2y1 minus 3y2 plus y3. This is the answer. I hope it is clear up to now. I hope it is clear. I hope it is clear. I hope it is clear. I think so. Now here, now I will give you the one question. Now I will give you one question. Now you have to say me the answer. Okay. Now the question they have given: heat of combustion, heat of combustion, heat of combustion of carbon and CO are minus 393.5 and minus 283.5 kilojoule per mole. Kilojoule per mole. Calculate heat of formation. Calculate heat of formation of CO per mole. Calculate the heat of formation of CO per mole. Calculate the heat of formation of CO per mole. Now same. Calculate the heat of formation of CO. Calculate the heat of formation of CO. In the meanwhile, I will search the remaining questions based on this concept. Okay. Now say me the answer. Minus 110 kilojoule per mole. Minus 110 kilojoule per mole. Okay, good. S law also we can use. We can use the S law. You are saying, sir, we can use the S law also. But he's asking just why to use the S law. He is asking just enthalpy of combustion data they have given, and is asking the formation of CO. Formation of the CO. Formation of the CO means here the carbon should be in the graphite, right? Plus half O2 gas, half O2 gas. Then now this is the enthalpy of formation. But data they have given on the basis of the combustion, right? Data they have given on the basis of the combustion. Combustion data if they have given, now the enthalpy of the formation or enthalpy of the reaction if they have given, then here the enthalpy of the combustion or enthalpy of the standard formation of the oxygen will be taken as 0. Done. Then here carbon heat of combustion is minus 393.5 because number of moles is 1, minus CO enthalpy of formation is minus 283.5. Then if you do, you will get it as a enthalpy of combustion, you will get it as minus 110.5. 110.5 you will get. Okay. Now next one, the next question. Next question. If C diamond, this is C diamond, gives rise to C graphite. This is C graphite. C diamond gives rise to C graphite is X kilojoule per mole. Okay. When the C diamond is converting into the C graphite, X kilojoule per mole. Next one. C diamond plus O2 gives rise to CO2 gas. Now it is when it is converting in this one, y kilojoule per mole. CO2 gas, y kilojoule per mole. Next, C graphite plus O2 gas gives rise to CO2 gas, that is plus Z kilojoule per mole, that is plus Z kilojoule per mole at constant temperature, then which relation is correct, they are asking. At constant temperature, which relation is correct? Option A, x is equal to y plus z, B is equal to minus x y plus z, C, x is equal to minus y plus z, D, x is equal to y minus z. Now same. Now which relation is correct for this one? Which relation is correct? How the D? First reaction sign change చేస్తే ఫస్ట్ రియాక్షన్ సైన్ చేంజ్ చేస్తే క్యాన్సిల్ అయిపోతుంది. ఫస్ట్ రియాక్షన్ సైన్ చేంజ్ చేస్తే క్యాన్సిల్ అయిపోతుందా? ఏం క్యాన్సిల్ అయిపోతుంది? సి గ్రాఫైట్, సి డైమండ్ క్యాన్సిల్ అవుతుంది. ఓకే, నువ్వేమంటున్నావు అంటే ఫస్ట్ రియాక్షన్ సైన్ చేంజ్ చేస్తే క్యాన్సిల్ అవుట్ అయిపోతుంది. ఓకే, క్యాన్సిల్ అవుట్ అయిపోతే మరి నీకు వచ్చేది ఏంటిది? సి 2 moles ఆఫ్ సి గ్రాఫైట్ ప్లస్ 2 moles ఆఫ్ O2 గివ్స్ రైస్ టు CO2. దాన్ని నీకు ఆన్సర్ ఎక్కడ వస్తుంది? మైనస్ ఎక్స్ ఈజ్ ఈక్వల్ టు వై ప్లస్ జెడ్. మైనస్ ఎక్స్ ఈజ్ ఈక్వల్ టు వై ప్లస్, సింపుల్, ఒకటే, ఏం లేదు. ఇప్పుడు ఈ లాస్ట్ రియాక్షన్ ఒక్కటి ఇక్కడ చూడు, లాస్ట్ రియాక్షన్ నువ్వు ఇంటర్చేంజ్ చేస్తే, ఇఫ్ యూ ఇంటర్చేంజ్ ద లాస్ట్ రియాక్షన్, సిడి గివ్స్ రైస్ టు సి గ్రాఫైట్ నీకు కావాలి, సి డైమండ్ ఇజ్ ఈక్వల్ టు సి గ్రాఫైట్ కావాలి. నీకు లాస్ట్ రియాక్షన్ ఇంటర్చేంజ్ చేస్తే ఏమవుతుంది? CO2 గ్యాస్ ప్లస్ CO2 గ్యాస్ గివ్స్ రైస్ టు సి గ్రాఫైట్ ప్లస్ O2 గ్యాస్ కదా. ఇక్కడ సి గ్రాఫైట్ ఇక్కడ సి గ్రాఫైట్ క్యాన్సల్. నెక్స్ట్ CO2 క్యాన్సల్. అంతే. ఇప్పుడు సింపుల్, ఒక్కటే. ఇఫ్ యూ interchange the first one, what you will get? C graphite will be cancel out. C diamond will be cancel out. Then the reaction will become x is equal to y plus z. Then x minus y plus z also you can write. Answer DA. But other than first reaction, if you change any other, you will get the answer or not. ఆ ఫస్ట్ రియాక్షన్ చేంజ్ చేసినా కూడా వస్తుంది, కానీ అదర్ దాన్ ఇంకా వేరే ఎనీ అదర్ సోర్స్. నెక్స్ట్ ఇంకొక మోడల్ టైప్ క్వశ్చన్ చూద్దాం. వీ కెన్ గెట్ అదే లాస్ట్ రియాక్షన్ చేంజ్ చేసినా వస్తుంది. Last 2 reactions will be cancelled out. Next question. Next type of the question we are having. Next type of the question what we are having? A 2CO gas plus O2 gas gives rise to 2CO2 gas. Okay, it's a delta H1 is minus X kilojoule per mole, right? B1 they have given C graphite plus O2 gas gives rise to CO2 gas. Its delta H2 will be given as minus Y kilojoule per mole. Minus Y kilojoule per mole. He is asking the delta H naught for the reaction. Delta H naught for the reaction C graphite plus half O2 gas gives rise to CO gas is. Now see me. Should I give the options or will you try? Will you try or should I give the options? Okay, I will try to give the options so that it will take less time. You can try. Meanwhile, you can try. I will give you the options also. You can cross check. Option A, x minus 2y by 2. Option B, x plus 2y by 2. C, 2x minus y by 2. D, 2y minus x. 2y minus x. Answer A. Good. Answer is A. Answer is A. Right. The first one you have to interchange. Sign change and divide. Good. Sign change and you have to divide. Good. Right. You have to do the side change and you have to divide. Most of the questions will be from these two concepts only. I hope that these two concepts data has been clear. Next one. Last question I will give you and I will move to the enthalpy of neutralization concept. Next one. Now S gas plus 3 by 2 O2 gas gives rise to SO3 gas plus 2x kilocalorie they have given. Now SO2 gas plus half O2 gas gives rise to SO3 gas plus Y kilocalorie. My dear friends, I am able to see that 6 members are seeing my live, but the only I am getting the reply from only one person. See, I am not teaching for only one person. If any students who are listening the class, if you don't know, just give me the question mark so that I can based on your mindset also I can say you. So I am thinking that only the one student is listening, so I was teaching to him. Actually this above question I can solve, but already that the one who is giving the answer, he got the answer right, so that I am thinking that he got, so no need of explanation for him. If you are getting any shy, just at least give me the question mark so that I can give the explanation for our question. I will give the explanation for this one. So if not, if you give the question mark or anything, I will say him to wait so that you guys can try. Okay, fine. Done. Okay. Now let's try this question. Same data. You have to use this one only. The laws of thermochemistry I was explained, right? No, not this one. Where is it? These are the only this you have to remember. What? Now first one, when the reaction is added, enthalpy of the reaction will be added. Now if the reaction is subtracted, now next one, if the stoichiometric coefficient if you have multiplied, then heat of reaction if you have divided, this only you have to use in this data, that's nothing is there. Okay, now he is asking the heat of formation, the heat of formation, the heat of formation of SO2 gas is given by, okay, for this reaction the heat of formation of SO2 means this SO2 should be, formation is saying, right? Formation means one thing you have to remember, formation means it should be at the product side. Now here you can see the SO2 is at the reactant side, so you have to interchange this reaction and you have to eliminate and you have to give the answer. Now the option A is 2x by y kilocalorie. Option B, y minus 2x kilocalorie. Now C, 2x plus y kilocalorie. D, x plus y kilocalorie. Okay na? Now send me the answer. Now, if you know the answer, give me the, say me the answer. If not, give me the question mark. Now the Pranit, you can give the answer, no problem. Say me the answer. If you are there, say me the answer. What is the answer you are getting? Cancel అయితున్నా కానీ ఆప్షన్స్ మ్యాచ్ అవ్వట్లేదా? 2x minus y you got. How come? How come 2x minus y? Now we'll see. Better, we'll see the question. Now here in the first one if you interchange, second reaction if you interchange, you need the formation of SO2, right? The formation of the SO2 means you should have the sulfur here and you should have the O2 here. Done. Then here already S gas plus 3 by 2 O2 gives rise to SO3 gas. Then if you interchange the second one, it will become 2x. Now if you interchange the second one, then it will become SO3 gas gives rise to SO2 gas plus half O2 gas, right? Now here SO3 gas will be cancelled. Then SO2 is there, okay, fine, SO2 is there. Then here it is a 3 by 2, 2x minus y I got, but 2x minus y option is not there. 2x minus y option is not there. Now let's see. Here it will be cancel out. Then here the 3 by 2 and half O2 will be the half O2, it will become half O2. Then what you have to do is just it will become minus 5. Then minus y 2 by 2 O2. So 102 only, no sir, ante SO2 na, formation of SO2 is asking. So 3 by 2 O2 and half O2, it will be get cancelled. 3 by 2 O2 and half O2, how much it will give? 3 by 2 O2 and half O2. It will give 1 O2, right? It will give 1 O2, then it will be cancelled. 2x plus 2x minus y. Correct only. Maybe options misprint, I think so. Maybe this one is minus. Okay, we'll see. This is the question from Disha's question number 69. From the Disha, the question number 69 actually this is. Then actually that book maybe misprint, I think so. Misprint has happened. Oh, sorry. Uh, Here the sign conventions, here it is a enthalpy of formation is asking, right? Or heat of formation is asking. Page number A61. No, it is correct only. Option B is correct actually. Now why the option B is correct? Here the plus sign it is given. This plus sign indicates that in the enthalpy of the formation. Now here it will be the minus, right? It will become minus. Exothermic. The plus indicates that it is a exothermic, so negative, and here it will become the positive. Actually the sign convention, if you do the reverse, it will become the what? Negative. Wow, the negative, right? Now it will become the positive. So it will become the positive. Enthalpy of the reaction H1 plus H2. 2x minus of minus y. Minus of minus y, it will be the plus. So the answer B is correct. Answer B is correct. So you have to be very careful with the sign conventions also. Sign conventions also you have to be very careful. Done? Right. Now, next one. Now the next concept we are going to see, that it is enthalpy of neutralization. Now this enthalpy of neutralization concept is very important, and a n number of the questions they are asking from this enthalpy of neutralization, and many of the students they will get confused in the enthalpy of neutralization concept. So enthalpy of neutralization concept, how to identify the questions from the enthalpy of neutralization. What is the meaning of the enthalpy of neutralization? At particular temperature, the amount of heat energy required to release when 1 gram equivalent of acid neutralized to the 1 gram equivalent of base. So if suppose HCl plus NaOH, third one, that is a enthalpy of neutralization. Enthalpy of neutralization. Neutralization reaction means acid base reaction, right? Neutralization reaction means acid base reaction. So enthalpy of the neutralization HCl plus NaOH, aqueous, both are strong acid versus strong base. It will give you the NaCl solid, NaCl plus H2O. So here when this reaction is happening, whatever may be the heat it is coming from the reaction, that it is only due to the which one, that it is only due to the H plus and the OH minus ion reaction. Why? Here HCl is a strong electrolyte. In the solution it will be converted into the H plus and the Cl minus. Now the NaOH Na plus and the OH minus, right? Now the NaCl solid is also a strong electrolyte. It will be converted into the Na plus and the Cl minus. Now we know here already here the Cl minus we are having, Cl will be cancelled. Here Na we are having, Na we are having. So in the solution, whatever may be the, it is reacting to give the H2O, right? So the enthalpy of the neutralization is happening, or it is taking place only due to the when 1 mole of H plus, 1 gram equivalents of H plus and 1 gram equivalents of OH minus reacting to give the H2O liquid. When this reaction is happening, now the enthalpy of reaction or heat released from this reaction, this is experimentally given, you have to remember. Most of the cases they will give you minus 13.7 kilocalorie, minus 13.7 kilocalorie or minus 57.3 kilojoule. This much of the energy will be released. This much of the energy will be released. Done? Clear? Now, next case. Whenever here this is 1 mole and 1 mole. Let's suppose H2SO4 they have given. H2SO4 plus KOH. This is also one strong base. This is a one strong acid. Clear? When they are reacting, it will give the K2SO4 aqueous plus H2O liquid. K2SO4 aqueous, H2O liquid. Done? Now, here you may think that here the 2H plus are there. So, 2H plus plus OH minus gives rise to 2 moles of H2O2 and you will put the here 2, right? But this is wrong. This is wrong because you may think that H2SO4 N factor is 2. So here the 2 moles of enthalpy of formation will be happened. So you may think that for 1 mole of enthalpy of formation is minus 57.3 kilojoule and minus 13.7 kilocalorie, right? And you may think that you will multiply 2, but this is actually, it is wrong. Actually it is wrong. Why it is wrong means, when we are dealing with the gram equivalents, when we are dealing with the gram equivalents, for the 1 gram equivalents, for 1 gram equivalents of H2SO4 require 1 gram equivalents of base, then 1 gram equivalents of the salt will be formed. 1 gram equivalents of the salt will be formed. 1 gram equivalents of the H2O will be formed. So irrespective, when we are dealing with the normality, no need to consider the N factor of the acid. When we are dealing with the which one? Normality, no need to consider the N factor. This is very key point you have to remember. Done? Here whatever it may be, that it is due to the H plus and it is due to the OH minus and it will give you the H2O liquid. H2O liquid, same delta H minus 13.7 kilocalorie per mole energy will be released and minus 57.3 kilojoule that heat will be released. Okay, now here this is a concept only due to the H plus ion and the OH minus ion reacting to give the H2O liquid. Due to this only this much energy is released. So here how the questions they will ask you, how the questions they will ask you, now we will see. Here based on these questions, based on this concept only, most of the questions are, most of the students they will get confused whenever this type of the enthalpy of neutralization they have given. We'll see one question based on this concept. Let me check the question. One nice question they have given. What is the one good question they have given? The enthalpy of neutralization. The enthalpy of neutralization of NH4OH. This is a weak base with HCl is minus 51.46 kilojoule per mole. Okay, and enthalpy of neutralization of NaOH, enthalpy of neutralization of NaOH with HCl is minus 55.90 kilojoule per mole. Okay, now he is asking enthalpy of ionization. This is a one very simple question. So whenever this type of the question they have given and the neutralization concept data they have given. So neutralization concept data they have given and they are asking the enthalpy of ionization. So what is the meaning of the enthalpy of ionization? First of all, ammonium hydroxide. This is a weak base. When it is reacting with the HCl, what it will form? It will form the ammonium chloride, right? Plus H2O it will form. So here from here OH, what it will form here? First of all, here this reaction to convert into the ammonium chloride plus H2O. Here two types of the data they have given. What are the two types of the data they have given? One is enthalpy of neutralization of ammonium hydroxide is minus 51.46 kilojoule per mole, and enthalpy of neutralization of this H2O is minus 55 kilojoule. But enthalpy of ionization is asking. So what is the meaning of the enthalpy of ionization? Means here this NH4OH, before it is in the form of the base. So first of all this we have to convert into the aqueous, right? We have to convert this into the ammonium ion aqueous, and we have to convert into the OH minus, right? Means here this ammonium hydroxide which is in the form of the base, now to convert into the constituent gaseous, what we have to do? This one we call it as a enthalpy of ionization, right? This one. Clear? Now here this base, what it is there, to convert into the constituent gaseous ion. From this constituent gaseous ion only we are converting into the aqueous species like this, right? Now we are converting into this aqueous species, right? In this manner, OH minus is converting into the H2O. Now base is converting into the constituent ion. Means here this reaction to happen when this enthalpy of ammonium chloride, when it has formed, that reaction has evolved this much of the heat, right? Means if I want to calculate the enthalpy of the reaction for this one, the enthalpy of the reaction is equal to enthalpy of ionization plus enthalpy of neutralization. Enthalpy of neutralization of H2O, how much they have given? Enthalpy of neutralization, how much they have given? You can see enthalpy of neutralization of H2O is minus 55. Directly you can take this as a minus 55. This is minus 55.90. Minus 55.90 directly you can take. They are asking the enthalpy of ionization. Enthalpy of neutralization of this ammonium hydroxide, already they have given that it is a minus 51.46, and is asking the enthalpy of ionization minus 55.90. That if you send it to the left hand side, the enthalpy of ionization is equal to how much you will get? something plus 4 you will get, something plus 4 you will get. I hope it is clear. I hope this question is clear. Or should I explain once again, or should I give some other question data based on this one? I hope this question is clear, or should I explain once again? Place of reaction, అదే కదా నేను చెప్తుంది. ఇప్పుడు క్వశ్చన్ ఏం అడిగిండు, ఎంథాల్పీ ఆఫ్ న్యూట్రలైజేషన్ ఆఫ్ అమోనియం హైడ్రాక్సైడ్ విత్ హెచ్సిఎల్లో ఈ న్యూట్రలైజేషన్ రియాక్షన్ ఇది చేసినప్పుడు దాంట్లో నుంచి ఇంత హీట్ వచ్చింది కదా, ఇది ఎంథాల్పీ ఆఫ్ రియాక్షన్. ఆ ఎంథాల్పీ ఆఫ్ మళ్ళా ఇక్కడ నుంచి వచ్చిన H ప్లస్ ఇక్కడ నుంచి OH మైనస్ రెండు న్యూట్రలైజేషన్ రియాక్షన్ అయ్యి ఇంత ఎనర్జీ రిలీజ్ చేసింది. అయితే ఇక్కడ క్వశ్చన్లో ఏమడుగుతున్నా, ఎంథాల్పీ ఆఫ్ అయనైజేషన్ అడుగుతున్నాడు. ఎంథాల్పీ ఆఫ్ అయనైజేషన్ అంటే ఏంది, ఇప్పుడు ఈ బేస్ని కాన్స్టిట్యూయెంట్ గ్యాసియస్ అయాన్గా కన్వర్ట్ చేసిన తర్వాతనే కదా ఆక్వస్ స్పీసీస్లో కన్వర్ట్ అవుతుంది. అది అంటే ఇక్కడ నీకు ఏదైతే ఎనర్జీ, ఎంత ఎనర్జీ కావాలి అంటే, ఇప్పుడు నీకు నార్మల్గా ఈ రియాక్షన్ న్యూట్రలైజేషన్ రియాక్షన్ అవ్వాలి అని అంటే నార్మల్గా నీకు ఇప్పుడు ఒక యాసిడ్, ఇప్పుడు నువ్వే ఇప్పుడు చూడు HCl ప్లస్ NaOH ఇది రియాక్ట్ అయిపోయి NaCl ప్లస్ H2O వస్తుంది. దీని ఎంథాల్పీ ఆఫ్ రియాక్షన్, ఎంథాల్పీ ఆఫ్ న్యూట్రలైజేషన్ వాల్యూ ఎంత, -55.40 ఉండాలి. ఓకేనా, ఎంత ఉండాలి, -55.90 ఉండాలి. ఎక్స్పెరిమెంటల్గా ఏదైనా ఒక యాసిడ్ కానీ బేస్, సరే మనకి ఇదంతా వద్దు కానీ ఇట్లా తీసుకుందాం, యాసిడ్ ప్లస్ బేస్ తీసుకుందాం, బెటర్. యాసిడ్ ప్లస్ బేస్ తీసుకుందాం. ఒక యాసిడ్ ఒక బేస్, స్ట్రాంగ్ యాసిడ్ ఒక ఏదైనా ఒక యాసిడ్ అయినా బేస్ రియాక్ట్ అయిపోయి ఒక సాల్ట్ ప్లస్ వాటర్ ఇచ్చినప్పుడు ఈ వాటర్ ఫార్మేషన్ వల్ల ఇంత హీట్ బయటకు వచ్చేస్తుంది. మనకి ఇంతే రావాలి. ఏ యాసిడ్ అయినా ఏ బేస్ అయినా కానీ రియాక్ట్ అయినా కానీ మనకి ఎనర్జీ ఎంత బయటికి రావాలి, -55.90 బయటికి రావాలి. కానీ మనకి ఇక్కడ అమోనియం హైడ్రాక్సైడ్ ప్లస్ HCl రియాక్ట్ అయినప్పుడు, ఒక బేసు ఒక యాసిడ్ రియాక్ట్ అయిపోయినప్పుడు మనకి ఇక్కడ ఒక సాల్ట్ ఫామ్ అయింది, ప్లస్ H2O కూడా ఫామ్ అయింది. మనకి ఎంథాల్పీ ఆఫ్ న్యూట్రలైజేషన్ మనం ఎక్స్పెక్టెడ్ ఎంత, 55.90. కానీ మనకి వచ్చిన ఎంథాల్పీ ఆఫ్ న్యూట్రలైజేషన్ ఎంత, -51.56, -51.46. మరి రావాల్సింది ఇంత, వచ్చింది ఇంత. క్లియరా, మనకి ఎక్స్పెరిమెంటల్గా రావాల్సింది ఇంత, కానీ మనకి వచ్చింది ఎంత, -51.46. అంటే ఇక్కడ ఈ 4 జోల్స్ ఆఫ్ 4 కిలో జోల్స్ ఆఫ్ ఎనర్జీ ఎక్కడ పోయింది, ఆ 4 కిలో జోల్స్ ఆఫ్ ఎనర్జీయే దీన్ని అయనైజేషన్ చేయడానికి, ఆ 4 కిలో జోల్స్ ఆఫ్ ఎనర్జీయే దీన్ని అయనైజేషన్ చేయడానికి యూజ్ అయింది. అర్థమైందా, వీక్ బేస్ కాబట్టి. స్ట్రాంగ్ బేస్ అయితేనేమో అది కంప్లీట్గా, స్ట్రాంగ్ బేస్ అయితేనేమో అది కంప్లీట్గా వచ్చేస్తుంది. దెర్ ఇస్ నో నీడ్ రిక్వైర్డ్ ఫర్ ద అయనైజేషన్. వీక్ బేస్ కదా, వీక్ బేస్ పార్షియల్లీ డిసోసియేట్ కదా, దాన్ని అయనైజ్ చేయడం కోసం ఎంత. క్లియరా, అర్థమైందా? రైట్. సో this type of the question they will ask. Next, okay, let me search the some other questions from this concept. If I give one or two more questions, it will be clear for you. చూస్తా ఒక 2-3 టైప్ ఆఫ్ మోడల్స్ ఆఫ్ ద క్వశ్చన్స్ ఈ కాన్సెప్ట్ మీద చేస్తే నీకు కూడా కాన్సెప్ట్ క్లారిటీ వస్తుంది. Wait, let me search. Enthalpy of neutralization. Enthalpy of neutralization. Right. Question. Calculate the enthalpy change. Calculate the enthalpy change when 50 ml of 0.01 molar calcium hydroxide reacts with 25 ml of 0.01 molar HCl. Okay na? Done. Given that enthalpy of neutralization of strong acid versus what they have given here, they found that enthalpy of neutralization for the strong acid versus strong base is 140 kilocalorie per mole. So calculate the enthalpy change. First A 14, B 35, C 10, D 7.5. Now see me the answer. See the LR. Based on the LR, you have to calculate. మిల్లీమోల్స్ లో తీసుకున్నా ఏం కాదు, మోల్స్ లో తీసుకున్నా ఏం కాదు, ఈక్వివాలెన్స్ లో తీసుకున్నా ఏం కాదు. మిల్లీమోల్స్ లో తీసుకుంటే యూనిట్, మిల్లీమోల్స్ లో కిలో క్యాలరీలో అడుగుతుంది కదా, ఇక నీకు యూనిట్స్ కిలో క్యాలరీలో ఇచ్చింది కాబట్టి దాని తర్వాత మళ్ళీ కిలో క్యాలరీస్ లో కన్వర్ట్ చేయాలి దాన్ని. ఫస్ట్ నీకు మోల్స్ లో తీసుకుంటే యూ హ్యావ్ టు మల్టిప్లై. ఇప్పుడు ఈ కాన్సెప్ట్ ని మోల్ లో తీసుకుంటే నీకు వచ్చిన ఎన్ ఫ్యాక్టర్ కానీ నీకు వచ్చిన హీట్ ఆఫ్ రియాక్షన్ కానీ మల్టిప్లై చేయాలి. ఒకవేళ ఈక్వివాలెన్స్ లో తీసుకుంటే నో నీడ్ టు మల్టిప్లై. ఈక్వివాలెన్స్ లో తీసుకుంటే ఎన్ ఫ్యాక్టర్ మల్టిప్లై చేయని అవసరం లేదు. బ్యాలెన్స్ అయ్యే రియాక్షన్ ని ఏం లేదు, జస్ట్ బ్యాలెన్స్ అయ్యే రియాక్షన్. నౌ ఇప్పుడు ఏమిచ్చినాడు, హెచ్సిఎల్ ఇచ్చినాడు. హెచ్సిఎల్ ప్లస్ CaOH taken twice. Okay, done. Now it will be converted into the CaCl2 plus HCl plus H2O కదా, ప్లస్ H2O. ఇక్కడ నువ్వు ఈక్వివాలెన్స్ లో తీసుకో ఆర్ మోల్స్ లో తీసుకో. ఇప్పుడు ఇక్కడ 1 mole ఆఫ్ HCl రిక్వైర్డ్ హౌ మెనీ, ఇప్పుడు ఇక్కడ నువ్వు ఇది 2 తీసుకుంటే ఎల్ఆర్ కాన్సెప్ట్ చూడు. అయితే ఎల్ఆర్ తీసుకో, మోల్స్ తీసుకో, దీని మిల్లీమోల్స్ తీసుకో. దీని మిల్లీమోల్స్ ఎంత వస్తుంది? 25 ml. 25 ml, సరే మోల్స్ తీసేసుకో డైరెక్ట్. దీని మోల్స్ తీసేసుకో. దీని మోల్స్ ఎంత వస్తుంది? 0.01 ఇంటూ 25/1000. దీని మోల్స్ వచ్చింది. ఎంత అయిపోతుంది ఇది? 25 ఇంటూ 10⁻⁻5 అవుతుందా? 10⁻⁻5 moles అవుతుంది, కరెక్టే. Now this one will become 25 into 10⁻⁻5 moles. Now this one will become n factor ఉంది కదా, ఇక్కడ 2 కదా. దీని ఈక్వాలెన్స్ లోకి తీసుకొస్తే now I have converted this into the equivalence. Now దీనికి 2 into 50 into 10⁻⁻5. Now all as came into the equivalence. Now in this equivalence, this one will be the LR. Means here whatever may be the H plus, it has came from the HCl. Same 25 into 10⁻⁻5 equivalence of OH it will be reacted, right? OH it will be react. అంటే ఇప్పుడు ఇక్కడ 25 into 10⁻⁻5 నుంచి వచ్చిన HCl ఈక్వాలెన్స్ ఈ అదే సేమ్ 25 into 10⁻⁻5 ఇందులో నుంచి ఈ రెండు రియాక్ట్ అయ్యి ఇంత ఇచ్చింది కదా. అంటే ఇన్ దిస్ రియాక్షన్ 25 into 10⁻⁻5 moles of H plus will be completely neutralized. So the enthalpy of the reaction will be 140 into 25 into 10⁻⁻5 చేస్తే నీకు వచ్చేస్తుంది ఆన్సర్. అర్థమైందా? మళ్ళీ ఒకసారి ఎక్స్ప్లెయిన్ చేయనా? షుడ్ ఐ ఎక్స్ప్లెయిన్ వన్స్ అగైన్ ఆర్ ఇట్ ఇస్ క్లియర్? ఇంకో క్వశ్చన్ ఇవ్వనా? బేస్తో నీకు సంబంధం లేదు కదా. నేను ఏం చెప్పినా ఇట్ విల్ బి క్యాన్సల్ అవుట్. ప్రోడక్ట్ సైడ్ లో ఉన్న ఇక్కడ సిఏ క్యాన్సల్ అయిపోతుంది. నీకు ఈక్వాలెన్స్ అయితే ఈక్వాలెన్స్ లోనే డీల్ చేయి. ఈక్వాలెన్స్ కంటే నేను ఏం చెప్పినా, ఈక్వాలెన్స్ అంటే అక్కడ ఎన్ ఫ్యాక్టర్ తో పని లేదు. ఎన్ని ఈక్వాలెన్స్ ఉంటే అన్ని ఈక్వాలెన్స్ తో రియాక్ట్ చేయి. 1 ఈక్వాలెన్స్ 1, సో నో నీడ్ ఆఫ్ చెకింగ్ ఫర్ ద అదర్. ఓకేనా? వన్ మోరా? ఓకే, వన్ మోర్ క్వశ్చన్ ఇస్తా. వన్ మోర్ క్వశ్చన్ నువ్వు చెయ్యి. ఇట్ విల్ బి క్లియర్ ఫర్ వెయిట్. క్వశ్చన్ ఏంటంటే now the question is calculate the amount of heat. అక్కడ అమౌంట్ ఆఫ్ హీట్ ఇచ్చింది కాబట్టి నీకు కొంచెం కన్ఫ్యూజ్ అయింది. ఇప్పుడు అమౌంట్ ఆఫ్ హీట్ అడుగుతుంది. అమౌంట్ ఆఫ్ హీట్ దట్ విల్ బి రిలీజ్డ్ when 300 ml of 0.2 molar HCl is mixed with 200 ml of 0.2 molar HCl of 0.2 molar. Now here enthalpy of neutralization of HCl and NaOH is enthalpy of neutralization. So enthalpy of neutralization is equal to 57 kilojoule per mole. Now say me the answer. How much is the heat it is released is asking. How much is the heat it is released is asking. See the amount of heat that will be released when 300 ml of question is half data mixed with when 300 ml of when 300 ml of 0.2 molar HCl is mixed with 200 ml of 0.2 molar NaOH. When the 300 ml of 0.2 molar 200 ml NaOH. NaOH, sorry. Oh, say me the answer. Okay, 2 in kilocalories you say, in kilojoules you say, kilojoules. I think you got in joules. I think you got in joules. Same in the kilojoules. Nothing is there. What is asking? HCl plus NaOH when it is reacting, it will give you the NaCl plus H2O. Okay na? When the 1 mole of HCl, sorry, 1 mole of this reaction is happening, the enthalpy of the reaction is released 50 kilojoule, 57 kilojoule. But instead of 1 mole and 1 mole, if suppose 300 into 300 ml of 0.2 molar if they have given, then how much it will be? It will become 60 millimoles. 60 millimoles means 60 millimoles. This one will become, how much it will become? 40 millimoles. 40 millimoles means this one will be the LR, right? This one will be the LR. Means how much it will be formed here? 40 millimoles of the product will be formed. So here what is asking, for the 1 mole 57 kilojoules of heat if it is released, then for the 40 into 10 to the power minus 3 millimoles, how much heat it will be released? That's it, simple. Nothing is there. Now for this one, if the enthalpy of the reaction released, for this one how much it will be released? I hope it is clear. For that LR you have to cross check and you have to do. Done. If you now let's suppose if you deal with the millimoles, means no need to consider the n factor. Okay, if you deal with the equivalence, no need to consider the n factor, but if you deal with the moles, then you have to consider the equivalence. So now I will give you this question so that whatever may be the doubts you are having, that it will be clear for you. Now calculate the amount of heat that will be released when 300 ml of 0.2 molar H2SO4 is mixed with 200 ml of 0.2 molar NaOH. Okay, now say me for this one. Now enthalpy of neutralization from this reaction is minus 57.32 kilojoule. Clear, this much energy is released. Now say me the answer. What is the answer? See, if you deal same like before only, NaOH is the limiting, so no need to consider the n factor. So same answer you will get. But if you do with the moles, method, 57.32 into 40 by 1000 you will get. If you deal with the moles, 120 millimoles, one will be the 40 millimoles, and the leftover will be the if you deal with the moles, then if you deal with the moles, how you will get 120 millimoles plus OH minus 40 millimoles, that it will give you the H2O, right? Now enthalpy of the reaction, now you have to see the LR, now here from the 120, 40 it has been reacted, leftover will be the 60, right? 60 is the equivalence of that one. Leftover acid, leftover product it is formed, you have to see. So 40, here the 40 will be formed, right? So for the 1 it is giving minus 57.32, then for the 40 how much it will give you? Okay, that 40 millimoles, how much it will give you, that you have to calculate. I hope it is clear. Done? Clear? Next one. The next concept we are having for this one. Next one is a very important concept. Many of the direct questions they may not ask, but if this concept is clear, that type of the concept questions, if they ask directly, you can predict. What is the concept we are going to see? That it is a heat of dilution. So what is the meaning of the heat of dilution? See, at a particular temperature, the amount of heat energy released, or absorbed, when a solution containing 1 mole of solute is diluted from one known concentration to another known concentration, is called heat of dilution. Okay, with the heat of dilution concept, they are mixing with the heat of hydration. They are mixing the question from the heat of hydration. Now what they are mixing? They are mixing the concept from the heat of hydration. So what is the meaning of the hydration? When the ion it is mixed, or when the ion it is surrounded with the water molecule, now energy released, that we call it as a heat of hydration, right? So heat of hydration. This heat of hydration concept is very, very important. Heat of hydration. What is the meaning of the heat of hydration? At a particular temperature, the amount of heat energy released, this is very, very important. Now listen, when 1 mole of anhydrous salt, this is very, very important. 1 mole of anhydrous salt converted into hydrated salt, hydrated salt, right, is known as the heat of hydration. Now here, what is the meaning of the heat of hydration? Heat of hydration can be calculated by using different heat of solutions. So heat of hydration can be calculated by using different heat of solution. By taking the different heat of solution, we can calculate the heat of hydration. Sir, how to calculate for this one? First of all, now I have taken the one MgSO4. Okay, this is anhydrous, before one anhydrous one. For this anhydrous MgSO4, how much water molecule it is required? Let's suppose CuSO4 will take better. CuSO4 anhydrous, it is there. It is in the form of anhydrous. So if we pass it to the H2O excess, what it will give? Can anyone? What it will give? It will give the blue vitriol. So CuSO4 dot 5H2O it will give. So for the known solution, for the known compound, for this CuSO4, it requires the 5 moles of H2O. How much moles of the H2 water molecule it require? So 5H2O it require. So every time, how much moles of the, for every anhydrous compound, how much water molecule we required, we don't know. For that one, what we have to do, just instead of giving the 5H2O or how much it is required, we don't know. That's the reason what we are taking the water excess. We are taking the H2O excess. Then anhydrous MgSO4, when we are added in the water, in the excess of water, then first what it will be converted? It will be converted into the aqueous. That energy released, some energy released, that it is A. This energy released, we call it as a hydration energy. We know, right? How the MgSO4, how it will be converted? Mg plus. This Mg plus, now when we have added in the water, now in the water what it will be there? Now due to the hydration energy, what is the meaning of the hydration energy? Hydration energy, as the charge is high, hydration energy will be high. Right? Hydration energy will be high. Due to that, energy released. Clear? After hydrated, then here whatever may be, how much water molecule it has been utilized? Here energy released. First one, hydrated one, when we have added in the water, then it has converted into the MgSO4 aqueous. This is MgSO4 aqueous, it has been converted. This MgSO4, it require 7 moles of H2O. Plus water excess. Then if we want to what? This 7H2O, how much water it has required for this MgSO4 to make it as a MgSO4 aqueous? How many moles of H2O it require? 7 moles of H2O it is required, right? So to convert into MgSO4, so its delta H will be the sum B. Delta H will be the energy absorbed. It is energy absorbed. Clear? Now when the 7 water molecule, when it has surrounded, to remove it from this one, it is energy absorbed. So for us the required equation is MgSO4 plus 7H2O, because we are required only the 7 moles of H2O, but here we have taken the excess of H2O, but actually we required only 7H2O. To convert this equation into MgSO4 dot 7H2O. Now this enthalpy of the reaction will become, Now its enthalpy of the reaction will become. Now its enthalpy of the reaction will become. Now actually we required this equation. Now the enthalpy of the reaction will become B minus A. No, see, actually for this MgSO4 anhydrous, how much excess of the water we required we don't know. Actually we have added this. Okay, now first thing, this is a key point for this one. Actually in the advanced and the mains based questions, they are asking, actually if you want to find the heat of hydration of the any compound, first of all heat of hydration can be calculated by using the different heat of solutions. So first this one, this MgSO4 anhydrous లో ఈ MgSO4 anhydrous ని వాటర్ ఎక్సెస్ లో యాడ్ చేసినప్పుడు MgSO4 aqueous గా ఫామ్ అయింది. కానీ ఈ MgSO4 aqueous అనేది ఎన్ని వాటర్ మాలిక్యూల్ తీసుకుంటది అంటే ఆ MgSO4 ఎంత హైడ్రేటెడ్ కావాలి అని అంటే దానికి ఎన్ని వాటర్ మాలిక్యూల్ కావాలి? A మైనస్ బి, గుడ్. ఎన్ని వాటర్ మాలిక్యూల్ కావాలి? అట్లా దానికి యాక్చువల్గా MgSO4 అనేది 7 moles of H2O తీసుకుంటుంది. అది హైడ్రేటెడ్లో ఉన్నప్పుడు, ఇది ఎట్లా హైడ్రేటెడ్లో ఉన్నప్పుడు అది 7 moles of వాటర్ మాలిక్యూల్ తీసుకుంటుంది. ఎక్కడి నుంచి? MgSO4 aqueous ఇట్లా. అప్పుడు దీని ఎంథాల్పీ ఆఫ్ రియాక్షన్ ఏంది? ప్లస్ బి. అంటే నాకు కావాల్సిన రియాక్షన్ ఏంది? ఈ MgSO4 anhydrous ని ఒక వాటర్ ఎక్సెస్ లో వేస్తే దానికి 7 moles of వాటర్ మాలిక్యూల్ కావాలి టు కన్వర్టెడ్ ఇన్ టు ద హైడ్రేటెడ్. ఒక అనైడ్రస్ మాలిక్యూల్ ని హైడ్రస్ గా కన్వర్ట్ చేయాలి అని అంటే 7 కావాలి. నాకు ఇప్పుడు ఈ ఎంథాల్పీ ఆఫ్ రియాక్షన్ ఏమైతే రివర్స్ అయిపోతుంది కదా. ఇప్పుడు ఓవరాల్ దీని ఎంథాల్పీ ఆఫ్ రియాక్షన్ ఏమైపోతుంది? డెల్టా హెచ్ ఈజ్ ఈక్వల్ టు ఏమైపోతుంది? మైనస్ ఏ ప్లస్ మైనస్ బి కదా. ప్లస్ బి ఉండాల్సిన ఎనర్జీ కాస్త మైనస్ అయిపోయింది. సో ఎంథాల్పీ ఆఫ్ ద రియాక్షన్ విల్ బి ద డెల్టా హెచ్ ఈజ్ ఈక్వల్ టు ఏ ప్లస్ బి. ఏదైనా ఈ అనైడ్రస్ క్వశ్చన్ ఇచ్చినడు అని అంటే ఒక్కటే గుర్తుపెట్టుకో, ఫస్ట్ అనైడ్రస్ గా ఉన్నప్పుడు ఆ స్పీసీస్ అనైడ్రస్ గా ఉన్నప్పుడు దాని ఎంథాల్పీ ఆఫ్ రియాక్షన్ ఎంత, దాని తర్వాత దాని హైడ్రేటెడ్గా అయినప్పుడు దాని ఎంథాల్పీ ఆఫ్ రియాక్షన్ ఎంత. ఆ రెండింటిని ఈ ఫార్ములాలో పెట్టేస్తే డైరెక్ట్ ఆన్సర్ వస్తుంది. నీకు పెద్దగా ఇబ్బంది పడాల్సింది ఏం లేదు. ఓకేనా? క్లియరా? విల్ డూ వన్ క్వశ్చన్ బేస్డ్ ఆన్ దిస్ కాన్సెప్ట్. నీకు కూడా క్లారిటీ వస్తుంది ఒక క్వశ్చన్తో జస్ట్. క్వశ్చన్ ఏమి ఇచ్చిందంటే, క్వశ్చన్ దే ఆర్ గివెన్ ది hydration energies of K plus and Cl minus ఇచ్చినాడు. K plus Cl minus or minus X and minus Y. ఓకేనా? కిలోజోల్ పర్ మోల్ రెస్పెక్టివ్లీ ఇచ్చినాడు. కిలోజోల్ పర్ మోల్ రెస్పెక్టివ్లీ. అయితే ఇక్కడ ఏమడుగుతున్నాడు? ఇఫ్ లాటిస్ ఎనర్జీ ఆఫ్ KCl ఈస్ మైనస్ Z కిలోజోల్ పర్ మోల్, the heat of solution of KCl is try చేయి. heat of solution of KCl is అడుగుతున్నాడు. ఆప్షన్స్ ఏమేమి ఇచ్చినాడంటే ఆప్షన్ ఏ ఎక్స్ మైనస్ వై మైనస్ జెడ్, బి ఎక్స్ ప్లస్ వై ప్లస్ జెడ్, సి జెడ్ మైనస్ ఎక్స్ ప్లస్ వై, డి మైనస్ జెడ్ మైనస్ ఎక్స్ ప్లస్ వై. రాకపోతే క్వశ్చన్ మార్క్ ఇవ్వు, నేను ఎక్స్ప్లెయిన్ చేస్తా. డి ఆన్సర్ కాదు, డి కాదు. అంతే, లాటిస్ ప్లస్ హైడ్రేషన్ ఎనర్జీ. లాటిస్ ప్లస్ హైడ్రేషన్ అంతే కదా సొల్యూషన్. ఇప్పుడు ఏదైనా అయానిక్ కాంపౌండ్ నీకు సొల్యూషన్లో సాల్యుబుల్ అవ్వాలంటే నీకు డెల్టా హెచ్ నెగిటివ్ రావాలి. నీకు డెల్టా హెచ్ నెగిటివ్ రావాలి అని అంటే డెల్టా హెచ్ ఈజ్ ఈక్వల్ టు హైడ్రేషన్ ఎనర్జీ ప్లస్ లాటిస్ ఎనర్జీ కదా. హైడ్రేషన్ ఎనర్జీ ప్లస్ లాటిస్ ఎనర్జీ. ఇప్పుడు నీకు హైడ్రేషన్ ఎనర్జీ ప్లస్ లాటిస్ ఎనర్జీ చేస్తే నీకు డెల్టా హెచ్ నెగిటివ్ వచ్చిందనుకో, ఆ సాల్ట్ అనేది సాల్యుబుల్. కాకపోతే ఇక్కడ క్వశ్చన్లో నేను కొంచెం కన్ఫ్యూజ్ చేయడానికి ఇచ్చినాడు, అంతే, ఏం చేయలేదు అక్కడ. నీకు ఆల్రెడీ అక్కడ క్వశ్చన్లో ఏమి ఇచ్చిండంటే ఇఫ్ ద లాటిస్ ఎనర్జీ ఆఫ్ ద కేసీఎల్ ఈస్ మైనస్ జెడ్ అన్నాడు. ఫస్ట్ ఇప్పుడు ఏదైనా స్పీసీస్, ఇప్పుడు NaCl ఉంది నాన్న, NaCl సాలిడ్. ఇప్పుడు NaCl సాలిడ్ని ఫస్ట్ నువ్వు దీనికి లాటిస్ ఎనర్జీ ఇచ్చినావు అనుకో, Na ప్లస్ గ్యాస్గా Cl మైనస్ గ్యాస్గా కన్వర్ట్ అవుతుంది. దాని తర్వాత ఇది వాటర్ మాలిక్యూల్తోని కాంటాక్ట్ అయిపోయి ఏమైపోతుంది, ఇప్పుడు Na ప్లస్ విల్ బి సరౌండెడ్ విత్ ద H2O. ఇట్లా H2Oతో సరౌండ్ అయినప్పుడు ఏమైపోతుంది, ఎనర్జీ రిలీజ్ చేస్తుంది కదా, Na ప్లస్ ఆక్వస్గా కన్వర్ట్ అవుతుంది. ఈ ఎనర్జీ ఏమంటాం మనం, డెల్టా హెచ్ హైడ్రేషన్ ఎనర్జీ అంటాం. ఇదేంది, డెల్టా హెచ్ లాటిస్ ఎనర్జీ అంటాం ఇక్కడ. సో నీకు అక్కడ ఎంథాల్పీ ఆఫ్ సొల్యూషన్ ఈజ్ ఈక్వల్ టు డెల్టా హెచ్ లాటిస్ ఎనర్జీ ప్లస్ డెల్టా హెచ్ హైడ్రేషన్ ఎనర్జీ. డెల్టా హెచ్ లాటిస్ ఎనర్జీ ప్లస్ డెల్టా హెచ్ హైడ్రేషన్ ఎనర్జీ. అయితే ఇక్కడ డెల్టా హెచ్ లాటిస్ ఎనర్జీ నీకు ఏమి ఇచ్చినాడు, డెల్టా హెచ్ లాటిస్ ఎనర్జీ ఫర్ దిస్ వన్ ఏ క్వశ్చన్కి ఇచ్చినాడు, హైడ్రేషన్ ఎనర్జీ ఆఫ్ K ప్లస్ అండ్ X మైనస్ ఇచ్చినాడు. ఇఫ్ ద లాటిస్ ఎనర్జీ ఆఫ్ KCl ఈస్ మైనస్ జెడ్, లాటిస్ ఎనర్జీ ఆఫ్ KCl ఇచ్చినాడు, KCl సాలిడ్కి ఇచ్చినాడు. కాకపోతే నువ్వు కన్వర్టెడ్ ఇంటూ అయాన్స్ చేయాలి కదా, దాన్ని కన్వర్టెడ్ ఇంటూ అయాన్స్ చేయాలి కదా. అంటే ఇప్పుడు నీకు ఇక్కడ మైనస్ జెడ్ కదా నాన్న, నువ్వు దీనికి ఎనర్జీ ఇవ్వాలి. అంటే ఇది ఏమైపోతుంది, మైనస్ లాటిస్ ఎనర్జీ అవుతుంది, సారీ మైనస్ జెడ్ అవుతుంది, ప్లస్ హైడ్రేషన్ ఎనర్జీ K ప్లస్ ది ఎంత, K ప్లస్ ది X అండ్ Cl మైనస్ ఎంత, మైనస్ వై. ఇదేమైపోతుంది, మైనస్ ఇట్ విల్ బికమ్ ప్లస్ జెడ్ మైనస్ ఎక్స్ మైనస్ వై అవుతుంది, ప్లస్ జెడ్ అవుతుంది అది. సో ద ఆప్షన్ సి ఈజ్ కరెక్ట్. లాటిస్ ఎనర్జీ అంటే నువ్వు ఎనర్జీ ఇవ్వాలి కదా, ఇప్పుడు అది ఈ KCl సాలిడ్ అనేది K ప్లస్ ఆక్వస్ Cl మైనస్కి ఆక్వస్గా కన్వర్ట్ అవ్వాలి అని అంటే ఫస్ట్ దీన్ని నువ్వు గ్యాస్ లాగా కన్వర్ట్ చేయాలి, K ప్లస్ Cl మైనస్ గ్యాస్కి. అంటే ఇక్కడ నువ్వు లాటిస్ ఎనర్జీ ఇవ్వాలి. లాటిస్ ఎనర్జీ ఇచ్చిన తర్వాత హైడ్రేషన్ ఎనర్జీకి వస్తాయి అవి, ఇట్లా వాటర్తో సరౌండ్ అయ్యి. అంటే నువ్వు ఎనర్జీ ఇవ్వాలి కాబట్టి అప్పుడు ఏమైపోతుంది, నార్మల్గా మైనస్ లాటిస్ ఎనర్జీ అవుతుంది. ఓకే, లాటిస్ ఎనర్జీ అయాన్స్ దెన్ హైడ్రేటెడ్, గాట్ ఇట్, రైట్. ఓకేనా, రైట్. నెక్స్ట్ ఇంకేమన్నా క్వశ్చన్స్ ఉన్నాయా ఇలాంటి? ఓకే, నౌ బెటర్ ఐ విల్ 87 I కావాలన్నట్టున్నాయి ఒకటి వచ్చేస్తుంది. Now what I will do, Better I will stop the here now. Remaining portions we'll see tomorrow. Okay. It has become late. Okay, na? Now we'll stop the class here. Tomorrow we'll see remaining we are having mostly we are having only the bond dissociation energy, resonance energy, that we'll see tomorrow. Okay, fine, bye.